This is Reigate College Year 2 Pure 6 Maths, and we're covering integration using partial fractions. So I'm going to work through the two examples that we have in the course workbook. So we're going to use partial fractions where we are trying to integrate an algebraic fraction, and we've got to be careful that we want to make sure that it's not something that's in the form of f dashed of x over f of x. So where the numerator of the fraction is equal to the derivative of the denominator of the fraction. That's not the case here. So we're going to split this into partial fractions. So I'm going to do that working up at the side here. So I'm going to say x minus 5 over x plus 1, x plus 2 is equal to a over x plus 1 plus b over x plus 2. Then I'm going to multiply through by both factors on the denominator here, so that I get on the left hand side x minus 5 is equal to, on the right hand side, a times x plus 2, so that's the denominator of the b part, plus b times x plus 1, so that's the denominator of the a part. And then I'm going to substitute, so substitute, and I'm going to choose x equals this should be minus 2, shouldn't it? Let's go and correct what's a very easy error to make. Minus 2, you've just seen me do that, x minus 2. So I'm going to substitute x equals 2, so x equals 2. On the left hand side I get 2 minus 5 is minus 3 is equal to, this is 0, so I get 3b, so b is minus 1. And now I'm going to substitute x is minus 1, so here I get minus 6 is equal to, this is 0, and minus 1 minus 2 is minus 3, so it's minus 3a, so a is equal to 2. So what I can do now is I can go back to my integral and I can rewrite it. I can say this is equal to, well, I've got a is 2, so it's 2 over x plus 1. B was minus 1, so I can say minus 1 over x minus 2 dx. And both of these are things that I can integrate. So I can now integrate 2 over x plus 1 and say that's 2. That's 2 times 1 over x plus 1, so I'm going to get 2 ln of modulus of x plus 1 minus ln of modulus of x minus 2 plus a constant of integration. Now it would also be possible to write that like this. This is equal to ln of, it's going to be x plus 1 squared, x plus 1 squared, and minus, so divide by inside the log x minus 2, and then I would put a modulus sign around that whole thing, plus c. You might be asked to leave it in that form in the exam question, or any form might be fine. Let's go to question 2 now, and to keep this video from getting overly long, I'm not going to work through the partial fractions here. So again, I would suggest that you do your partial fractions working here. Partial fractions working. Often in an exam question they'll give you the algebraic fraction, ask you to split it into partial fractions for the first part of the question, and then the second part of the question might say now find the integral of this, where you're using the partial fractions you've already created. So the partial fraction for this, split this into 2 over 2x plus 1 plus 3 over x minus 2 minus 1 over x minus 2 squared dx. So what I'm going to do is, before I integrate, I'm just going to rewrite that last one as 2. So 2 over 2x plus 1 plus 3 over x minus 2 minus x minus 2 power of minus 2 dx. It's very easy to make the mistake of thinking that all of these are going to end up as, when we integrate them, as having a log function, but this one's not. Okay, so you often see people making a mistake that they end up with ln of x minus 2 squared. We're not going to get that. So here what we're going to say is we're going to have ln of 2x plus 1 modulus of 2x plus 1. When we differentiate that, we're going to get 1 over 2x minus 1 times 2, because we're going to use the chain rule, differentiate the inside, so that's where that 2 is coming from there. So we don't need a 2 in front here. Plus 3 times ln modulus of x minus 2. And then here, we're going to use the reverse chain rule. So we're going to say this is going to give us minus 2, increase the power by 1. We're going to have x minus 2 to the power of minus 1. When we differentiate this, we're going to get minus 1 times x minus 2 to the power of minus 2. So we're going to put plus here, because differentiating will give us that minus there. And then we're going to say plus a constant of integration, so I'm going to call that c again. And let's just rewrite that with a fraction here. So this is ln of modulus of 2x plus 1 plus 3 ln modulus of x minus 2 plus 1 over x minus 2 plus a constant of integration. Now often an exam question will have limits. You'll substitute in the limits, and the question might give you a specific form to put the answer in, so you're going to have to use laws of logs to rearrange it into that form. But that's enough on the specifics of the integration for the moment.